I want to welcome you to another exciting statistical topic. Today we are starting our last chapter. Okay, in the summer semester that we call chapter 6. So the topic is function of random variables. Now let me just tell us what our intention is here. You know, before now I've walked you through different kinds of random variable. Of course, in a stochastic world, okay, I told you the other time we live in a probability space, and of course, we basically can model our random experiment that we do in a stochastic world by random variable. Of course, I've walked you through different kinds of probability distribution. Random variable can actually follow. Now, you've heard about the discrete type, you've heard about the continuous type. I've walked you through the univariate situation where we have one measurement at a time, and I've also walked you through multivariate. What is new today? What is new today is if a random, let's say for instance, we have a random variable x, and this particular random variable x, okay, uh, follow a particular probability distribution. It may be discrete. If this guy is discrete, of course, it's going to follow a discrete type probability distribution. If it is continuous, it's going to follow one of the continuous type probability distribution. But you know what we want to do today? If x is a random variable that follow a particular distribution, we know the distribution then we now have a new variable. We got a new variable now, and that new variable is y. And you know what? This y is a function of x. Y, that's a new variable, is a function of x. Okay? And you know what we're seeking now? Okay. Um, with the idea of the probability distribution of x, can we figure out the probability distribution of y? Why do we need to figure out the probability distribution of y? Because we need the probability distribution. What if in case we want to find the mean of y, or we want to find the variance of y, or we want to find the standard deviation of y, and so on like that. So that is what we call the distribution, okay, of the function of random variable. And that's our intention today. So our intention is just like, okay, if I have a random variable x that follow a particular distribution, then I have a new variable y that depend on x. Okay, a new variable y that depend on x. And what we now want to do is using the idea of the probability distribution for x, can we figure out the probability? So what we're seeking now, this is what we're seeking now. We basically want to know the probability distribution of y, okay? And that is what we want to do today. To be able to do that, we actually have different method of achieving that. We can use the method of distribution functions. We can use the method of moment generating functions. We can use the method of transformation. Of course, we can also use the method of conditional function. Okay, you can also include the method of conditional function, method of conditional, okay, function. Okay, so like I said, we got different method that can be used to achieve that. Okay, now I want to walk you through this method. one after the other. Today, we're going to focus on the method of distribution function and the method of movement generating function. And of course, tomorrow, the focus will be on the method of transformation, where we're basically going to use Jacobian transformation. Now you know what our intention is. Now I want to walk you through uh, the method of distribution function. Okay. Now let me tell you this. Before I go into this method, I think I will need to relate this so that it doesn't look as if we're just doing math. Okay. I told you the other time, there's always a reason why we do what we do, right? We don't just do what we do. We don't just do math. There's a reason why we're doing math. So let me give you a one real life application of the distribution of the function of random variable. I want us to visit a gas station now. Okay, I want us to visit a gas station. Okay, we want to visit. Like I said, we basically want to visit a gas station. Give me 1 second. I'm going to stop my share so that uh, you know I want to confirm again. There's a few online. Can you still hear me? And can you also see the board?
Yeah, we can.
Okay, thank you so much. I want us to visit a gas station now. Okay, want to visit gas station. Okay, now let me tell you this. Let X. Okay, let X. Okay, denote the number. Let me just say the amount of gas stock. Okay, in a given week. Okay, in a given week at probably a specific gas station. Of course, they stock gas, right? They got a storage tank where they stock their tank. I mean the gas. Now, when you take a look at this guy now, uh, maybe the f of s is actually this guy, where x lies between 0, 1, and this is and 0 x square. Now, when you take a look at what I wrote here, okay, of course, you may be wondering why 0, 1. Okay, we if you want to look at it from percentage, okay, so the watts, they don't stock anything, and 1 maybe 100%. You get what I mean? So now, if you take a look at this now, okay, this is actually the whole variable x. Now, let's say the storage capacity, okay, of this particular gas station, which could be Holiday gas station or Speedway and so on like that. Okay, maybe they have a storage capacity for 10,000. Okay, for 10,000 gallons. Okay, so this is what they can actually. That is a maximum capacity. Okay, the amount of gas they can actually stock. Okay, now if you take a look at this 10,000, we basically want to define a new variable, and this variable is going to be y, which is going to represent cost. Okay, now this particular gas station, we want to assume that they bought maybe 1 gallon at $3, because I know in Minnesota now, I think a gallon should be more than, it's above $3. Now, if I want to determine the cost, okay, now one if you buy 1 gallon at $3, now this is what happened. If you want to consider the cost, you consider 10,000 by x. Don't forget, x is the maximum, I mean, is the amount of gas stock. Okay, and if the they have the maximum capacity for 10,000. Okay, then in a particular week, this is what they basically, depending on what the values of X is. Okay, now if you take a look at this now, okay, you're going to multiply this by 3. Where do I get the 3 from? 1 gallon is $3. Maybe that is the amount that they bought it. Does that make sense? And there is also a delivery cost that is fixed. Maybe $2,000. Okay, what I have right now. So if you take a look at this guy now, I got 30,000 X plus 2,000. This is Y. Okay, this is a new variable now, depending on X. You know what I want to figure out? What if in a situation, because if the amount of gas stock is a random variable, then we expect the total cost to also be a random variable. So if a total cost is a random variable, we want to begin to find what is the average cost. What is the variance of the cost? Okay, before I can figure out this guy, I need to figure out f of y. Okay, I need to figure out f of y. Okay, this is the application of what we're trying to do now. How do we figure out this? Without figuring out this, there's no way we're going to get anything that has to do with the cost. That's exactly what we want to do. Does that make sense? Okay, now how do we do it? Okay, how do we do it? We got 4 methods. Okay, we got the method of distribution function, the method of movement generating function, we got the method of transformation, and the method of conditional function. So what I'm going to walk you through now is, today we're going to focus on the method of distribution function, and we're also going to focus on the method of movement generating function, and tomorrow we're going to focus on the other one. Okay, so I'm going to go back now and share. I used to tell you math is easy. Okay, if you're able to you confirm. Can you see my lecture slide right now?
Waiting for it to load. Got it.
Okay, you got it. Thank you. Now I want to walk you through the method of distribution functions. You know our intention, right? The method of distribution function is one of the methods to figure out the probability distribution of a new variable y. Like I said here, I want to figure out the probability distribution of the total cost. Okay, now this is the way it works. Because before in this class I've walked you through the method, distribution function, CDF. The idea of the CDF will be used. The moment I get a CDF, okay, when I differentiate the CDF, that will lead to the PDF that I'm looking for. We actually want to come in from the CDF. Now, if you take a look at this, let U be the function of the random variable y1, y2 up to yn. Okay, just like the same way that we're trying to say y is a function of x here. We have to find the region. Then, and with the CDF, we're basically interested in the probability of a random variable less or equal, don't forget, less or equal to a realized value. Okay, and after that, after figuring out the CDF, what are we going to do? Then we're basically going to differentiate the CDF. So differentiating the CDF will give us the PDF. Now I'm going to walk you through an example right now. Take a look at this guy. A process of refining sugar yield up to 1 ton of pure sugar per day, but the actual amount produced Y is a random variable because of machine breakdowns and other slowdowns. Okay, it's going to be a random variable. We don't expect the machine to produce the same thing every day. Okay, because we live in a stochastic world, right? That is the reason, there could be breakdown. Machine could break down at times. They could be slowed down. Okay, that is the reason why there's a variation. Okay, that y now becomes a random variable, and the moment it is a random variable, then we can actually construct a probability distribution for it. Now that's f of y. F of y equal to 2y, and the support of y is from 0 to 1. Take a look at that. Now, if we have that guy now, the company is paid at the rate of $300 per ton for the refined sugar. Okay, but it also has a fixed overhead cost of $100 per day. There's the daily profit. Now, you know what we're interested in now? We're interested in figuring out the average profit or variance of the profit. Before you can actually get that, we need a probability distribution associated with the profit. And right now, they've given us a profit function, u to be equal to 3y minus 1. And in this situation now, you can see that u depends on y. Does that make sense? Okay, so you can see the 3 there is in $100. That's like 300, right? And the one, minus 1, of course, you're actually going to reduce the cost. Is it not? That's why you have a negative, right? Okay, now the question now asking you find the density function of u. Why are we interested in finding the density function of u? Because u is a random variable. We may want to find the average of u without the function, the probability density function of u. There is no way we'll be able to figure out the mean. Any question? Any question? Okay, now I want to use the method of distribution function to figure this guy out. Okay, now if you take a look at what I'm trying to show, I think the best thing, what I'm going to do is of course, you can read all of that, but I'm going to make use of my board. We've derived the f of u to be that, okay? That is the process. We use what I call the method of distribution function. But what I want to do right now, okay, I'm basically going to stop my share, and I'm going to, walk you through. Okay, now, you're actually giving f of y equal to y, okay, and this lie between days, and your profit is 3y minus 1. Okay, now we basically, what you want to do is you want to use the method of distribution function, okay, which is going to be f of u. Don't forget an uppercase f, which is going to be equal to probability of u less or equal to this. Okay, you remember that's a CDF, right? Okay, so right here now, I'm actually going to have 3y minus 1 less or equal to u. Okay, 3y minus 1, that's a u, right? Then I'm actually going to make y the subject of the formula. Okay, I'm going to make y the subject of the formula. Okay, when I make y the subject of the formula now, I'm afraid I'm basically going to have this guy. Okay, can you see that? I'm basically going to have this guy. I want to find the probability of y. When I want to find the probability of y, I can make use of the function of y here. Okay, so take a look at that. So this guy now is going to translate into, okay, you're going to start, the lower point is 0, but I'm going to end up in this. I'm going to end up in this. Okay, now the f of y, okay, f of y, the y. Any question? F of y, the y. Okay, so if I have this guy now, so what is the next thing I'm actually going to do? Of course, I can put the value, the expression 2y. Okay, I can put 2 here and just put y here. Okay, and then the y. Okay, so now the moment I do that, then I integrate in this guy. Now, I think I'm actually going to have 2y squared divided by 2. Okay, 0 to u plus 1 over 3. I think in the hand, okay, the f of u now is basically, by the time you plug in that guy, this is what you're actually going to have. Take a look at that. Now, if you have this guy now, how do we distribute this guy? Okay, Okay, so you need to come back here. We need a state space for u. You know the state space for y, right? Want to know the state space for u. If I plug in 0 here, right? Okay, plugging in 0, -1. When you plug in 1, that's going to be 2, right? Okay, that's going to be 2. Okay, the state space now. Okay, so if I want to distribute this, I'm actually going to write this between -1 and 2. Okay, x less than -1, or this is going to be 0. S less than -1 and s greater than 2. You remember the way we normally write the CDF, right? Okay, this is the way we write the CDF. Now, if this is the CDF, okay, don't forget, we're looking for the PDF. The PDF is a lowercase f of u, okay, which is going to be d du, okay, an uppercase that, okay, so d du, okay, I basically want to differentiate this guy now, okay, that's what I want to differentiate, okay, so you want to differentiate that guy now, okay, and if you do your differentiation very well because of my time, okay, if you do your differentiation very well because of my time, you're basically going to have 2 into u plus 1 divided by 9, okay, so your f of u is now this with the with the state space of u lying between -1 and 2, okay, this is your f of u. Of course, if this is your f of u now, you can answer whatever question that you want to answer, like a question like, what is the expected value of u? What is the expectation of u squared? What is the variance of u? You can answer that question. Don't forget, this is going to be this the u, right? From -1 to 2, this is going to be this to this, u squared, f of u, du. And of course, you know that this is basically going to be this minus expected value of u all squared. Any question? Method of distribution function is easy. Go ahead. Oh, sorry. That was a mistake by me. Sorry. That should be you. That's all right. Yeah, thank you so much for that. It should be you, focusing on you. Okay. Now, does that make sense now to everyone? That is the way the method of distribution function actually work. Okay, I'll quickly move